thanks everyone for coming out this morning or afternoon if you're over in Europe to spend some time with me, spend some time with Chris, and learn a little bit about our Form 3 Plus, really the flagship printer for Formlabs, has been for a while. I'm excited to talk to you about it because it's a printer I've spent a lot of time with. I've been here about 4 years at this point. Form 3 was my first big product launch with Formlabs, and I spent a lot of time printing on the machine. And then seeing the updates we've made with the Plus version, the 3 Plus earlier this year, it's been a really great journey to be along. So excited to have you here to learn a little bit about the workflow and the machine itself. And so primarily what I'm going to walk through is just what it's like to be an owner, to be a user of Form 3 Plus, what that means in terms of consumables, in terms of maintenance, in terms of workflow, and hopefully give you a good picture of how easy it is to go from an idea to a prototype, or to a prop, or even to eventually scale up and use it for end-use parts, like a few of you, it sounds like you're working with it already for, or working with another 3D printer for. So the machine itself, you can see, it sits right here. We build it as a desktop 3D printer, and it is a really nice form factor. I've had them on numerous desks. I've had multiple on desks in the past. It is a printer that can go a lot of places, do a lot of things, just with access to wall power. And then to my left, your right, I've also got the wash and cure. So when we talk about the printer, we need to talk about the whole ecosystem, and that includes post-processing, materials, all of that. So I've got the form wash and the form cure, which are both parts of that workflow. We'll talk a little bit about how that actually plays into using the machine and carrying out that workflow later on in the conversation. In terms of the printer itself, it uses our low-force stereolithography system, which is an evolution of earlier SLA systems. If I open up the hood here, to give you a general anatomy lesson on the printer, all the optics, everything like that is tucked into the bottom of it underneath this tank. So the optics are tucked right now when not in use under this side of the printer. And they come out and move on a rail. We call this our LPU, our light processing unit. All of your optics are in there. That's a user replaceable, user serviceable part. So super easy to keep these machines up and running. If you do eventually need maintenance or replacement parts on it, pops out with a thumb screw and a few hex head screws. Really simple procedure. So our laser is in there. And if you're familiar with older models of SLA printers, more traditional industrial machines, usually you think of the laser being inverted from this, shining from the top down. One of the major innovations Formlabs made early to try to turn this into more of a desktop size printer was inverting SLA and shining up from the bottom. That allows you to use only as much resin in the tank as you need to complete a couple layers. You don't need to fill the entire usable volume, print volume of the printer. You can get away with a very small amount of resin. That resin itself goes into this tank. And so I mentioned talking about consumables and working with the printer itself. This tank is one of the really key ones. This pulls duty as a few parts of your machine. One, it's an optical surface. This film layer on the bottom is what that laser is actually shining up through. And that's holding your resin. Your resin is sitting on top of it. And so the basic function of the printer is the platform is coming down. It's creating a slight gap between the tensioned film at the bottom of the tank and the platform itself. And then our laser is shining upwards and curing resin in between. That's how we repeat each layer. The platform pulls away from the film. It can peel away easily and without much force because it's a film. We actually can adjust the tensioner motor and slack that film for the peeling process to really make sure that we're not stressing your parts at all. And we'll just repeat like that. A couple nice things about this system. One is, so the tank is holding your material that's actually in use, which is a fairly small amount. The tanks just go in and out by sliding from the front of the printer. The actual reserve of material, the material the way that you buy it from us, comes in these containers that we call cartridges. This cartridge has a cap up top, sort of like a shampoo bottle. It's a flip top, but that's just to let air come in and circulate. The way it's actually dispensing is through a valve on the bottom. It's a bite valve right in there. And what's neat about this is with a system like Form 3 Plus, you can have your cartridge in, you can have your tank in. There are chips on each that you're detecting which kind of material. And that bite valve is feeding directly into the ramp at the back of the tank. I'll show you that again. It's this little surface right here. And it may seem like I'm going into a little bit of minutia here around the actual construction of the printer, but I get a lot of questions all the time. What kind of maintenance is required? What does it take to swap materials on this printer? How easy is it for me to start a print? And the really nice thing here is it's all automated. The goal is that you're not handling resin, you're not touching it, you're not bringing it out into your room or your workspace. What you're doing is inserting both consumables, letting it dispense a preset amount of resin into the tank, and letting it top it up for you as it consumes resin throughout a print. That makes it really easy to get going with the right amount of resin. You're not pouring by hand or trying to do any sort of measurement yourself. It also makes it very easy to swap materials. Talking about those older SLA designs that I mentioned a little while ago, when you're filling those up with resin, when you're filling an open volume with resin and using it, in order to swap materials, you would need to purge that. You need to flush it from the machine, usually causing a lot of waste or labor around trying to reclaim it. With the Formlabs SLA systems, switching materials is very easy on all of them because at no point is the resin actually contacting the printer itself. It's contained in these two specific components. So to swap materials, all I'm doing is taking out the tank. Each tank comes with a UV resistant case that they can go in and you can set aside on a shelf. And the resin can live in there for a fairly significant period of time. It's not really a concern having excess resin sitting in the tank. Cartridge can come out as well, and we could set both of those aside. And if we wanted to swap materials, we would just reinsert a cartridge of a different type. The machine knows what kind of resin is in there based on the chip at the bottom. It also knows the balance of how much resin is in there, the volume left over. And we would insert a corresponding tank for that material. So it's really quite easy to keep using this machine as a flexible tool in your workflow. And I know a lot of you mentioned that you were doing prototyping applications, which is a really great thing to hear. What I like most about using this printer for prototyping applications or for a wide range of projects is that flexibility. Formlabs has a huge library of materials. We've got quite a wide range from things like our rigid 10,000 material, which is a highly glass reinforced, very stiff plastic, to things like our flexible 80A, which is a rubbery, soft, very flexible material. And so having a tool where you can swap from an extremely stiff glass reinforced to a very soft and compliant, almost rubbery material is really powerful when you're doing those prototyping or other sort of flexible applications where you might want to design something with multiple features. It might be a stiff thing with compliant soft touch grips because you're making an ergonomic device. It might be in a range of colors, or maybe you want a clear window right in the middle of an opaque enclosure. There are a lot of things you can do just by swapping out materials on this. And what I tend to see when people start working with Form 3 Plus is they'll come in with one material in mind that's really exciting to them. Maybe they're excited about using one of our tougher, durable engineering materials, or maybe they think draft is really cool because it prints so quickly. And what they'll quickly do is discover that the range of materials is so wide and it's so easy to get a cartridge, get a tank, throw them on the shelf and have them as you need them. They're actually swapping between materials quite often, and they're able to explore and expand the number of applications past the one they initially came with. So, the goal is to really have a flexible tool that doesn't involve a lot of labor on your part to use it for whatever project comes up. In terms of setup for a print, once the tank is in and the cartridge is in, you're pretty much set. The only other thing is to make sure that you've got your build platform set in there. Build platform is just a sheet of aluminum with a plastic housing that locks into this latch up here on that vertical lead screw that raises it and lowers it during printing, as I mentioned before. We call it the Z tower. Put that in, lock it down, very easy. And all these parts that I was showing you previously, these are on build platforms. It's a great thing to have extras around. In our print farm here in Somerville, we keep a rack of them on the wall. We've actually got a 3D printed part that we use to hold them. They slide right on. And so the nice thing is, I can run my print. I can have my build platform rise up full of printed parts. I can take it off and bring it to go post-process and drop another build platform straight in its place. Start another print without really any manual steps. Check the level of the resin in the tank and in the cartridge on my touchscreen here, and hit go again with the saved file that I've uploaded to the printer. So real workflow, it's a really simple workflow designed around keeping uptime on the machine. And I know a couple of you mentioned end-use parts in there. We've seen a lot of people go to actually cells or large farms of these printers for end-use part production, especially in places like medical, dental, things like that, where they're creating single-use devices or that are highly custom to a patient, just because it's really easy to keep them running print after print with minor labor between. I want to talk now a little bit about the post-processing workflow. I promised I'd mention the remainder of what that experience looks like. And I think this is a really integral part of what working in a Formlabs printing ecosystem is. We have really tried with all of our printers to think out the entire workflow for you so that you don't have to be jury rigging or customizing that or taking it outside the ecosystem and having problems in that way. So we develop our own software, we develop our own materials and produce them in Ohio, actually. And we obviously develop the printer and the post-processing hardware. The goal is that you have this complete ecosystem where when you put material in the printer already knows what it is, has settings tuned perfectly for it. And when it comes out and you go to post-processing, there's no guesswork involved. You know exactly how long to wash for, you know exactly what kind of cure settings to use to get the mechanical properties you want, and it's all documented and repeatable. So I mentioned washing and curing. Washing and curing are essential steps with a resin-based printer because when the part comes out of the printer, it's going to be coated in a little bit of excess liquid resin. That liquid resin sits on the surface. It's just a byproduct of printing. It's the same material that you use to produce it. And it's just a thin film that you want to remove before doing your post-processing. The way we typically handle that is we take our parts on the build platform and we drop them directly into our form wash system. You can sit up here, and what we'll do then is we'll take this knob down below and set the amount of time that we'd like to have it run for on the screen here, and then tell it to start. And what it's going to do is lower this platform into a bath of usually isopropyl alcohol. Some people use other solvents like TPM. Lower it into the bath of isopropyl alcohol and agitate it. There are impellers at the bottom of this to agitate that isopropyl alcohol and make sure that you get a good clean on your parts. It's going to run, it's set and forget, you put it in and walk away. And then once it's finished running, it's going to raise your parts up out of that alcohol automatically and close the door behind it. It's a really great feature over manual washes or other methods of getting solvent off, because you're not standing there scrubbing, you're not sitting over a tub or a container of open alcohol. You can start it and walk away just like your 3D printer and go back to the other work that you'd rather be doing and come back when it's finished. The other nice thing is you can set it, forget it, walk away. And if you're gone for an hour or two, way longer than the roughly 10 minutes that you need to wash these parts, it's not going to hurt the parts. They've already been raised out and they're sitting there drying, getting ready for the cure. After that, what we will usually do is take it and remove them from the build platform. We include a number of tools to do that with the printer itself when you purchase one. Other users have improvised their own tools that they prefer. Usually things like putty knives or scrapers, just to leverage and pop them off the platform. The platform is designed to let the parts adhere just as much. And a huge part of our settings tuning, again, going back to that ecosystem of ours, a huge part of our settings tuning when we develop a new material is making sure that we get good enough adherence that you're going to have a print be successful every time, but not so much that it's difficult to remove. A lot of thought goes into, from the ground up of materials design, making sure that these materials are good to post-process, good to use, easy to be successful with. Once those parts are off the platform, they go into this very similar looking machine, which is our Form Cure. The Form Cure is simply a heated chamber surrounded on all sides with LEDs of the same wavelength as our laser. What you're doing there is essentially completing the chemical process that you started with the printer. So the laser on a Form 3 Plus cures resin. It creates a chemical reaction. The resins are photoreactive that causes cross-linking. It causes the resins to harden. And that gets it enough that those parts are solid. They're easy to handle. They're ready to be handled and post-processed, but not enough that you unlock the full mechanical properties of it. And so putting them in the cure is a way to enhance those mechanical properties, harden up the surface, reduce any tackiness left over from your washing process, and essentially make them ready to go, ready for hard use in a variety of applications. Curing time varies between materials. It can be as short as 10 or 15 minutes to as long as an hour, depending on what kind of properties you want. And we've published curves of material property gain on our website if you want to check out what curing is actually doing to the mechanical properties of a material as it goes through that process. Once you're out of the cure, you're essentially done. Your parts, if you printed them on supports like this one, will have supports attached to them that you can then remove using small tools, or in a lot of cases, just your hands. There's a lot you can do in our software Preform to customize support touch point size and all of that for easy removal. But we've also done a lot of smart design around the touch points of those supports and improvement over time to make them easier and easier to pull away. From the shape of it, making sure that if we're leaving anything at all, it's a positive, not a pockmark out of your parts, to the way that we truss them and have them interconnect between each other to maximize strength while allowing you as few actual contact points on your model as possible. So, once it's out of the cure, the mechanical properties are complete and the part is totally clean. All that's left to do is detach it from supports if you printed with them, or if you printed directly to the platform, like in the case of these rigid 10K bottle openers, just take them out of the cure and they're ready to go. Hopefully that makes sense as a brief overview of the workflow. To recap, we upload a model from Preform to the printer. It's stored on the touchscreen in the internal memory of the machine. That's just a set of instructions for what the printer should be doing with the laser and all of its motors. We insert build platform, cartridge, and tank. The cartridge and tank correspond to whatever material you're planning to use. They're easily swapped by pulling the tank out the front, pulling the cartridge out of the top, and replacing them with a different material. Once the print is done, it will be on this build platform. We can take that out, move to the wash, move to the cure, and complete the actual process there. I want to mention as well that some of the parts I showed here, this rigid 10K bottle opener, this is one of the standard samples that we print in huge quantities at that plant in Ohio that I mentioned for people to evaluate. We've always considered samples to be a really great way to understand the quality of the machine, understand what we're able to achieve with these materials of ours. And if you'd like to see one of these parts, maybe this bottle opener, it's getting warmer out, at least here in the States, and people are opening more bottles around this season, or something else. We've got a really wide range in all those materials. Maybe you work in a controlled industry and you want to see some of our biocompatible materials or something like that. You can actually request one.